Welcome to Chemist once again. So today we want to look at the cooling curve and the heating curve. In the previous lesson, we were talking about the kinetic theory of matter. We talked about the three states of matter in terms of their property or characteristics, structure, arrangement, movement, shape, and volume as the properties. And we talked about the interconversion of substances from liquid to solid, solid to liquid, liquid to gas, gas to solid, and solid to gas, and vice versa. And we talked about sublimation, which is the change of state from solid direct to gas, and vice versa, or from gas to solid without passing through liquid phase. So today we want to look at the cooling curve and the heating curve. So the following diagram shows the temperature changes when a substance undergo changes in state. So you have to know how to interpret graphs. So the y-axis here is temperature, the x-axis here is time, and then as you can see, the zero is the corner here, the starting point. But if you look at this, it is starting above, way above zero there. So and then we have the lines, dotted lines drawn to meet the horizontal plane. So here we have the melting point, then we have from here up to this level, when you meet the horizontal line in this direction up to here. So from here and there, this is completely a solid. If it's ice, it's a solid. So now once it reaches the horizontal line like here, this is the melting point, and the temperature here remains constant. Give a reason why temperature remains constant here, okay, between this region, because you need much energy to break the bonds of the particles or the forces holding the particles together. So at this horizontal line also we have two states. We have solid, a mixture of solid and a liquid, but from here up to there we have completely solid. Now once now the bond has been broken, the temperature now starts rising again up there, and it reaches the horizontal line like this. So from here, this line is showing boiling point. Now from this region, okay, from this region, from horizontal line, it starts rising from this region up to this horizontal line. We have completely a solid. This has changed into completely, a liquid, sorry. It has completely changed into a liquid. At this second horizontal line here, we have a mixture of states. We have liquid and a gas. Okay, so here also temperature remains constant for some time, for the same reason that you need more energy to break the bonds to change the state. Then from here now, this slope here upward there, the temperature now rises, and if from this corner up to the end of this graph line, we have completely a gas. So in an exam they will bring regions to say A, B, C, D, E, F. Then they start asking you questions, okay, in what states are present between B and C. So your answer is simply solid and liquid. What state is between this is A, B, C, D, D, E. Between D and E, you say liquid and gas. Okay, sometimes they can ask you what state is here, is gas. What state is here, is liquid. What state is here, is solid. Sometimes they can ask you, give a reason why temperature remained constant at this point here where you are seeing a horizontal line. Okay, this is because much energy is needed to break the bonds holding the particles together. Hence the temperature will remain constant, it will not rise. So as simple as that, someone who is supposed to get a distinction in science. Others have obtained distinctions from me, so what can stop you from getting a distinction too? So it's the same way I'm teaching, and then the next thing is the commitment on your part. You are able to answer questions and submit. Sometimes you find a question, answer and show me. I will not shy away to look at it or to advise you. That is what the A student, a distinction student, ought to do. So at parts where the graph rises, the heat supplied to the substance to raise the temperature, the graph becomes flat when the substance undergoes a change of state. The graph remains flat as heat is taken to overcome the interaction between the particles. I've explained this part. So the following diagram shows the temperature changes when a pure substance undergoes cooling. So this is a cooling curve. It's sloping downwards. It's a cooling curve. So from highest temperature to it's coming down more like steps coming down, that is cooling curve. Then the other one here is heating curve, starting from the lowest point, the bottom, going up is heating curve. Temperature is rising, that is a heating curve. This is how you identify a cooling curve from a heating curve or graph. So we look at now this. So as usual, we have horizontal lines as well there. We have, this is the melting point like this. So the explanation for this, okay, we are saying at parts where the graph falls, falling, okay, heat is given out from the substance to the surrounding. So giving of heat from the giving out of heat from a substance to the surrounding is exothermic type of reaction. So its temperature decreases because it's losing heat. So the graph becomes flat when the substance undergoes the change in state. The graph remains flat in particles to form bonds. So why temperature remained constant there? Because there was bond formation, okay, producing heat which is given out to the surrounding. So number one, what processes are involved? Melting occurs at the melting point. Particles absorb heat and vibrate more vigorously, allowing them to overcome particle interaction or connection, holding them in fixed position. So what happens when heat is applied to, for example, one state of matter? Okay, since that energy that is being supplied is kinetic, so the particles will start vibrating, moving vigorously. So that is how you explain. Then freezing occurs at the melting point. Particles release heat and move more slowly because they don't have energy. If you don't have energy yourself, you have not eaten, you will not be able to move, you will not be able to do activities because you don't have energy. So similarly, when it's at melting point, the particles release heat and move more slowly. Interparticle interaction formed and particles are forced to be held in a fixed position in an orderly arrangement, and there is a bond formation. So in freezing, that is bond formation. Sometimes they will tell you to state whether it is bond breaking or bond formation. Freezing, that is bond formation. Boiling occurs at a boiling point. Particles absorb heat and gain more kinetic energy. Then particles move faster enough to completely overcome the forces of attraction. Why are they moving faster? Because now they have acquired kinetic energy due to supply of heat. Then evaporation occurs below the boiling point. Particles at the surface gain sufficient or enough energy to escape into the surroundings. Then condensation occurs at the boiling point. Particles release heat and move slowly. The forces of attraction are able to hold the particles closely together. So under condensation, that is what happens. So in the next lesson, we'll be talking about diffusion. We'll talk about diffusion. Then once we finish that, we'll talk about, I'll proceed to talk about experimental techniques where we need to study the pieces of apparatus and their uses. They bring such kind of questions, the collection of gases, okay. Then in the next topic, purification, okay. So we'll move faster. Topics will be coming maybe like in full. So it's up to you now to practice, answer questions. That is what is remaining. Thank you so much for your attention.